So what we want to find is the concentration of the base. How many moles the liter will have. And we know what? The pH. Seems like similar like the other one, doesn't it? Right? So we start with what we know. What's the pH? pH is equal to 15. And if you use your calculator, you should find concentration of hydronium ions. Let's put this way to get faster. This one here. Reasonable, reasonable. Very small because it's a base. Okay. We want to go to the base, so we're going to use what? The ion product of water, right? The ion product of water. So from there, we can solve for the hydroxide ion concentration equilibrium. And that will be equal to that will give you 10 moles per liter. Well, that's a reconcentrated, isn't it? Now, because the concentration of hydroxide in equilibrium is equal to total, why is that? Well, it's concentrated base, right? And it's 10 to minus 7 moles per liter when it's just water. And now you put a lot of base, the concentration of hydroxide ion that comes from water is practically zero. Right? And so the only one that comes is from the base. So that's why the equilibrium will come equal to the total. The equilibrium, the equilibrium is the total and also is equal to what? That which comes from the base. Because the water doesn't count. It's so little. Ionization of water is totally suppressed. So these things are really nice to understand. The equilibrium is the total. And the total is from these two, right? Now, as we said, this one here is about 0. Because it's much, much less than 10 to minus 7. Minus 10 to minus 10, 10 to minus 12, whatever. So you ignore it. Therefore, the concentration of hydroxide ions that comes from the base is equal to 10. And therefore, the concentration of the hydroxide, the base, will be equal to OH minus from the base divided by 2 is equal to 10 divided by 2 is equal to 5. That's it. This is 1100. That's right, interesting. There's it, see? The day after tomorrow will be the TED Talks right here, in this room. Interesting, yeah. The problem is that we'll have it closed area, so I wanted my students to come and they cannot come. Even if they don't have seats, they have closed the area, so you cannot come. Otherwise, I will tell you to come. Yes.
Why did you divide by 2?
I expect that somebody to ask that. Even though it's so simple, I know a lot of students have that question. Isn't see it this way, the concentration of these it's easier to understand it like this. The concentration of these from these is is equal to 2I is the concentration of this. That's easier to see it. Why it's this is twice as the concentration of that? Because each one of them gives you 2. Right? MOH2 gives you 1M plus 2H minus. So per one of these, you have 2 of these. Right? In other words, concentration of this divided by concentration of that will be 1 to 2. Right? Concentration of this divided by that concentration 1 to 2. Can you see it?
Yeah.
Okay.
Thank you.
Okay, let's do part 1. Are you holding good? Yes? Or are you going to sleep now? Are you ready to go to sleep? Should we go home or continue? All right, let's see. So we have a chemical equation. They're all gases. That's very important to look, especially when you say delta and G. Delta and G, make sure that you know the physical state of all the components, right? So delta and G, so we try to find out the correct answer, right? Okay, delta and G is equal to 1. Is that true? No, delta and G is equal to how much? That's 3 minus 2 plus 1. They're all gases, so it's going to be 0. So it's not 1. It says increasing the volume will increase the amount of C. Increasing the volume will increase the volume of C. Well, let's see. If you increase the volume, right, which way will go, right or left? If you increase the volume, the total pressure goes down. The system says, I don't like it. I want to be where I was. So it's going to try to increase its pressure. That means it's going to try to increase the number of particles. Which way do you increase the number of particles? Going to the right or to the left? Doesn't matter. Right? It's the same. So what's going to happen? What is going to happen? You have to be careful when you read the problems. So you increase the volume, right? The thinking we did was correct. And the problem says increase the volume, increase the amount of C. Is that true? What happens to C? Huh? Be careful, it's tricky. Not tricky, it will be challenging. Because either way, you give you 3 moles, so there is no preference. The position of equilibrium will stay the same. What does it mean? Their relative amounts will stay the same. And most books, they're not doing it right because they're confusing amounts and concentration. So if you're not careful, you will not understand. So you change the volume, delta N G is equal to 0, and for that reason, the position of equilibrium will not change. It's not going to be either right or left. That means the relative amounts will stay the same. Will the concentration change? You better believe they will change. Right? The concentration will change. Because you have the same number of moles of each component, but now it's a bigger volume, so the concentration is going to be lower. Right? Okay, so so nothing will happen to the amount of C. It's going to stay the same number of moles if I increase the volume, because delta N is equal to 0. So that's not the answer. Increasing the volume will decrease the amount of C. Well, we know nothing will happen. Increase the temperature will decrease the K equilibrium. So this V has to do with the effect of temperature of the equilibrium constant. You remember? So it says increase the temperature. Okay, here is heat. You increase the temperature. What do you mean? You put energy in the form of heat. So you put, well, the system will say, I don't like the heat you put me. So I will go this way or that way to reduce that. Which way will you reduce it? This way or that way? This way you produce more. You want to eliminate that which you put in. So we'll go that way. Right? So we'll increase what? If it goes that way, more of this, less of this, so we'll increase the K equilibrium. It will not decrease. Can you see that? So that's not the answer, and it should be the last one. Decreasing the volume, right? Decreasing the volume. The number of moles of each stays the same, but the concentration will go up. So that's the answer. Pretty good problem?
Is there a situation where E wouldn't be correct?
Huh?
Is there a situation where E wouldn't be correct?
E would not be correct?
Yeah.
Well, if you say decrease the volume will decrease the concentration of gas, it will be wrong. Right? So the answer is E.